The title of selected topic is Application of Differentiation. So let's begin with the calculus origin. So the calculus was invented by the Sir Isaac Newton in the 1600s and helped with the Edmond Halley, which is the French astronomers on that day. As the first main purpose, the calculus is to calculate the trajectory of the Moon and Earth as the origin. Newton came to calculus as part of his investigation in physics and geometry. But Newton realized that math in 1600s not work out with his work, so he created calculus. With the calculus also, the motion of the orbiting planets around the Sun can be calculated because it works the same way as our Moon orbiting system. Application of differentiation. Differentiation origin. One of the most serious issues in Isaac Newton's day was inadequate maritime navigation. They using the constellation as their navigation, but there was not a good enough understanding of how the Earth, stars, and planets move with respect to each other every day. As to solve this problem, differentiation and integration was developed by Isaac Newton to improve this understanding. Differentiation and integration can also help us solve many types of real-world problems. So, what is differentiation and how to differentiate? The differentiation is a process of finding a function that outputs the rate of change of one variable with respect to another variable. Differentiation or the derivative is the instantaneous rate of change of a function with respect to one of its variables. This is equivalent to finding the slope of the tangent line to the function at a point. It also allows us to find rates of change, like finding the rate of change of x with respect to y, which on a graph of y against x is the gradient of the curve. There are a number of simple rules which can be used to allow us to differentiate many functions easily. If y equals to some function of x, then the derivative of y is written pronounced dy dx. So how to differentiate? If we have some function of fx equals to x to the power of n, where n is a power and x is an integer. First, we must multiply the power and the integer, like n multiplied with x. The second is, after the multiplication, then the original power must be minus with 1, which is x to the power of n minus 1. For example, we have a function which is y equals to 3x cubed. So we have to multiply the power with the integer, like 3 multiplied with 3, so we get 9, and the power must be minus with 1, so we get squared. So why we use differentiation? First, we are able to find the maximum and minimum possible values of any function using differentiation. We are also be able to finding the maximum and minimum values of a function. For example, one might wish to calculate the maximum profit and the other is to find minimum loss for his business. In general way, differentiation is used to divide in quantity into number of two parts. We are using differentiation in case a value changes with respect to another value simultaneously. For example, we have a function which is y equals to 3x cubed, and we can separate it into two functions, which is y equals to 3x cubed, and the second is dy dx equals to 9x squared. Application of differentiation are made in many engineering and science problems, especially when modeling the behavior of moving objects. These are the topics that using the application of differentiation, like tangents and normal, Newton method, curvilinear motion, related rates, curve sketching using differentiation, and radius of curvature. So for the conclusion, the application of differentiation is so important to these 8 topics mostly. So let's go to the problem statement. To show the application of differentiation, we must choose the topic which apply the application of differentiation. The topic which is the related rates. The related rates is meaning that if two related quantities are changed over time, the rates at which the quantities change are related. For example, if a balloon is being filled with air, both the radius of the balloon and the volume of the balloon are increasing. In this section, we consider several problems in which two or more related quantities are changing, and we study how to determine the relationship between the rates change of these quantities. So for the real life problem statement, saying that Randy will helping his brother blowing some balloon for his brother party. The balloon were 0 in radius at first. Randy also want to know how fast the balloon will be bigger as he blowing. Saying also that Randy will blowing that balloon at a rate of 150 cubic inches per minute. When the balloon's radius is 6 inches, how fast is the radius of the balloon is increasing.
So for this question, the information was given is 150 cubic inches per minute, which is this is our dv/dt. And then the question asks the radius of the balloon is increasing, which means that this as dr/dt. So before we doing the solution, we should find volume of the balloon, which is this is a volume of sphere. I let you think the formula volume of sphere in 10 seconds. Get it? So the formula volume of sphere can be written as V equals to 4/3 pi r cube. So we need to find dv/dr. Why dv/dr? Because we want to differentiate value of r in this formula. So 4/3 pi r must differentiate 3 r and power 3 minus 1, and we can get 4 pi r cube, r square. Maybe someone asks why we don't differentiate the pi, because pi is the constant. Just write it in the formula. Next, apply to the chain rule, which is this formula. So dv/dt is 150 equals to dv/dr, which is 4 pi r square multiplied by dr/dt. So that dr/dt (4 pi r square) we borrow to the left, which is 150 over 4 pi r square equals to dr/dt. Okay, look at the question again. When the radius is 6, so enter 6 in the formula. When r equals to 6, 150 over 4 pi 6 square equals to dr slash dt. And continue. 150 over 4 pi 36 equals dr slash dt. Okay, continue the operation and you can get dr slash dt equals to 25 over 24 pi or other answer is 0.3316. Don't forget the unit. Inches per minute. Since the question don't mention the answer in watt, so either of this answer was acceptable. Conclusion is, since dr slash dt equals to 0.3316, the rate of radius balloon blew by Randy is 0.3316 inches per minute every time, which means that when Randy blew the balloon, this is the radius was increased 0.3316. Done.